Next is surface tension. Surface tension is concerned with only liquids, as gases do not have the free surfaces. We know that liquid have no definite shape but have a definite volume, so they acquire a free surface when poured in a container, and these surfaces possess some additional energy. Molecules on a liquid surface have some extra energy in comparison to the molecule in the interior. So a liquid tend to have the least surface area. As an extra energy associated with the surface of liquids, so creation of more surfaces, keeping the things like volume fixed, requires the additional energy. Surface tension is represented by S, and it is defined as the surface energy per unit area of liquid surface. So S is equal to surface energy divided by area of liquid surface. In the figure, we have shown a wire having the film, and there is a sliding wire. The sliding wire experiences a force inward which try to keep the surface area minimum, and by applying the external force, the wire is shifted right side by a distance d. So surface energy can be defined as the force acting on the wire and the displacement. This is the total work which is saved as the surface energy, and the area change is the length. Now it is 2L because side is L and the film has two interfaces. This is air liquid interface upward, and then liquid air interface. So this length is counted twice multiplied by the distance d. So this gives the total area. So we can write that surface tension can be also written as F by 2L, or force per unit length. Unit of surface tension is Newton per meter, and it can also be written as Joule per meter square. And dimensional formula can be written as N m minus 1. This is the Newton per meter. It can be written as ml t minus 2 into L minus 1. This implies that dimensional formula of the surface tension is mt minus 2. Let's take some problems. First question is, a thin liquid film formed between a U-shaped wire and a liquid slider supports a weight of 1.5 into 10 to the power minus 2 Newton. The length of the slider is 30 centimeter and its weight is negligible. The surface tension of the liquid film is. This is the sliding wire which has the length of 30 centimeter and weight is given 1.5 into 10 to the power minus 2 Newton. Surface tension is, as earlier discussed, that it is F by 2L for the thin film because it has two interfaces, and it will be equal to, this force is the weight, that is 1.5 into 10 to the power minus 2 Newton divided by 2 into, and length of the sliding wire is 30 centimeter, so in meter it is 0.3. And on solving, if we remove this decimal and cancel by 3, it becomes 5. So we will have 5 by 2 into 10 to the power minus 2. It is equal to 2.5 into 10 to the power minus 2, or it is equal to 0.025 Newton per meter. Hence option D is the correct option. Next question is, two circular plates of radius 5 centimeter each have a 0.01 thick water film between them. Then what will be the force required to separate these plates if surface tension of water is 73 dyne per centimeter? We have defined that surface tension is surface energy per unit area, and this surface energy will be force into separation, this is D, divided by the total area, and total area will be, because area of the circular plate is A and there are two interfaces between the plate water and water plate, so we have the total area 2A. This implies that the force required to separate the plates will be F equal to S into 2A by D. Surface tension S is given 73 dynes per centimeter. So we can write it is 73 into 1 dyne can be written in terms of Newton as 10 to the power minus 5 Newton, divided by centimeter can be written as 10 to the power minus 2 meter. So it will be equal to 73 into 10 to the power minus 3 Newton per meter in SI system. Similarly, other values are given. Radius is 5 centimeter. So we can write it is 5 into 10 to the power minus 2 meter. Thickness D is 0.01 millimeter. So we can write it is 0.01 into 10 raised to the power minus 3 meter, or simply 10 to the power minus 5 meter. And now we substitute these values. Here S is 73 into 10 to the power minus 3 into 2, and area can be calculated as pi r square. This will be pi into, and radius is given 5 into 10 to the power minus 2. So it is square. That means it is 25 pi into 10 to the power minus 4. So substituting this value here, this is 25 pi into 10 to the power minus 4 divided by, and the separation is 10 to the power minus 5. So we will write it is 73 into 50 pi. If we multiply 2 with 25, it is 50. And the 10 to the power, this is minus 3 and minus 4 minus 7, and this is minus 5. So it becomes 5 when we bring it in numerator, and total power of the 10 will be minus 2. And further simplifying, we will have 115 Newton. Hence option C is the correct option.